By the way, we'll learn something fantastic today. It's called under exponents. It is called, ladies and gentlemen, the law of exponents. And by the way, those of you that haven't experienced the volleyball game, you get to see the volleyball girls in here. You'll understand what we talk about when we talk about the lack of excitement and enthusiasm. But I believe they've turned a corner.
We've been getting better.
I just want to prep yourself for that. Those of you who haven't watched them play volleyball before, it's strange. It resembles much like math class. By the way, my suggestion is for one of your cheers, you do the shake it up baby thing.
No, we'll do that.
Yes!
Come on, Chase. All right, write this down, please. Laws of exponents are this, that, and these. All right, let's say you are doing this. X to the third power times x to the fourth power. Okay. Here is one of those times where your first thought is usually wrong. Okay? It's not necessarily, it is logical if you think about it, but it's not obvious just looking at it. You should write that down. That sounds good. It's not.
Ooh.
No.
No,
It's a good start, though. All right. Which means this. If you asked me this when I was in 7th grade, I would tell you the answer to that is should be x to the 12th. Why? Because I'm multiplying it. 3 times 4 is 12, yes? How many of you were thinking 12? Or was not anybody thinking? Did anybody think 12? Come on.
Yeah. No.
Thank you, Soph. Well, most of you didn't think about it at all because you don't try anything until you're told to or whatever. I don't know. But you would say, well, 3 times 4 is 12. But if you think about this, Joseph, think about this. Look, x to the third power means what? 3 x's times themselves, right? X times x times x. X to the fourth power means what? 4 x's times themselves. I'll just do the speaking for you because if you multiply 3 x's times themselves times another 4 x's times themselves, how many x's are you multiplying times themselves? 7. This is x to the 7th power. Okay. In which case, well, let's do one more. M to the 8th power times m to the 5th power. Using that same logic there, you can put those together, and you're going to end up with, who thinks they got a shot at this one, Chase?
M to the 13th power.
Thank you very much. M to the 13th power. Okay. That would be the correct answer, rather than doing all those x's written out there. So, what do you suppose the first law of exponents that we're going to write down is? This is taking what you just kind of did and we're putting it into words so that quite possibly the next time you see it, you will understand what to do, right or wrong. Madison.
You're just adding the two numbers.
So how am I going to say that mathematically?
You are taking the exponents and adding them together.
When I do what?
When you multiply.
Well, first of all, they have to be like bases. In other words, I can't do this. X to the third power times a to the fourth power is not x a to the 7th power. It is x to the third power a to the fourth power. You can't put those together. They are their own sort of thing. So they have to be like bases. So the deal would be this. When you multiply like bases together, key word here is you add exponents. And that would be your first law of exponents. By the way, you want to see the way the book puts it? And you might as well say yes.
Yes.
Because at some point you have to start thinking upper level math, because I think I've mentioned to you before, you are 7 years into 4, 4, 7, 8, 9, into your 16 years worth of math, so you're only halfway there at the best. Mathematically, math people would write it like this: x to the a power times x to the b power, because they want you to write down something that'll work for any number, and you can put any number for a and any number for b. What would that equal? X to the what power? No, not c, because that would be completely different than anything else. Anybody? Wait, let's go back. What did I do here to get this? So I'm going to do this with this. Guess what I get when I add a plus b together? Grace? No, that would be multiplying a times b. Don't overthink this, Connor. There's no numbers there. Aaron, you got something here? That's it. It's x to the a plus b power. You can't put a and b together. I mean, well, when they're numbers you can, but as letters you can't. They just want you to see that. Whatever the numbers are for a and b, you're just going to add them together. You know, if it was 6 and 7, you get 13. If it was 9 and 9, you get 18. Blah, blah, blah. Wow. There. Now we're ready for the next one. How about this? So that was multiplication. What about division? What about x to the 5th power over x to the 3rd power? In division, ladies and gentlemen, I have to see how far they take you on this. Oh. Anybody got a thought? Help me out here. Lauren Elizabeth. X to the 2nd. Why that, Lauren? Ooh, I like the way Lauren thinks. It is. Actually, believe it or not, it is x to the 2nd power. If you think about this mathematically, or in terms of whatever, if you break this down, x to the 5th power means you have 5 x's, correct? Yep, Mr. Hunt, you are way on the right path there. Over x to the 3rd power means you have 3 x's, right?
Yes.
So what happens when you have the same factors over the same factors? They will cross off 1 for 1. And guess what you're left with? Like Lauren said, it is x to the 2nd power. So, based on that, what do you suppose the next law of exponents are? Madison!
When you are dividing the same bases together, you subtract the exponent.
Now you have to be careful with this. When dividing like bases, comma, you subtract the bottom exponent from the top exponent. When dividing, you subtract the bottom from the top. Which, mathematically speaking, does anybody think they can make the leap from what I just told you in the x? Wait, let me go back. What do you think? Here was multiplication and what multiplication looked like. What do you think the book will write down for division? Without looking in proverbial said book. Let me give it to you. Look, x to the a power over x to the b power is going to equal. Okay, making the deductive leap. Oh, Albert Einsteinian sort of people. Chase?
X to the a minus
X to the a minus b power. Yeah. So no matter what number you put in there. Now I don't want to scare you off with this, but what would happen if it was this? Let's change x's, let's put y. What if it was y to the 3rd power over y to the 9th power? Do we know what the answer to that would be? That it's not good. Follow the rule. A minus B, what's A minus B? You are seventh graders now. John says, believe it or not, it is y to the negative 6th power, because 3 minus 9 is negative 6, which I will just tell you right now, we don't like this. Not a good thing, but we're going to leave it with that. Now you ask, there must be more.
There must be more.
What about this? We've done multiplication, we've done division. Now we have to do exponents to exponents. Exponents to exponents, which means this. What if I have x squared to the 3rd power? X squared to the 3rd power. That is not the same thing. Get this out of your head. This is not this. This is not x squared times x cubed. Okay, it is x squared to the 3rd power. Do I have anybody out there that has a reasonable guess or thought as to what that would be? Grace likes to mouth the words that answer. You want to proclaim your answer? What was it?
12.
X to the 12th power. Why'd you come up with 12? Just out of curiosity. Somebody have a different shot. Aaron? X to the 6th power. How'd you come up with x to the 6th? X times itself?
No.
Madison, is that what you have?
No, I have x to the 7th power.
To the 7th. How do you get 7?
I did x to the 2nd power, which is 4, and then I added 4 and 3.
Just for fun.
7.
Well, if you think about what this is, children, take a look. What is x squared to the 3rd power? That means you have 3x squareds times themselves, which means this. You have x squared times x squared times x squared. Which, if you break it down even farther, means you have x times x, which is x squared, times x times x, times x times x. Which means, Aaron, it in fact is, it is x to the 6th power. Because you have 3 x squareds times themselves, and if you go back to our rule for multiplying exponents, you get that. Now, what do you suppose the rule is? Exponents to exponents get, a quicker way than writing all that stuff out, you would just do 2 times 3. They get multiplied. I don't know if I even spelled that right, did I? Looks like multiplying. Multiplied. Now here we go. Big leap. Written out mathematically using A's and B's. Can anybody? Is there anybody out there in this heart of math, children, is taking examples that you've seen before and following that same sort of little pattern till you get to where we're at here? Using A's and B's. Emily, can you use A's and B's in this instead of numbers and get me with the thing? Like when we did this. Like when we did this. Where'd it go? This. X to the A over X to the B equals X to the A minus B. Or like this, when I did XA times X to the B, I got XA plus B. How can I write that out with X's and whatevers? I can. Instead of 2 and 3, I'm going to put what? X to the A to the B power is going to equal what? It always goes south of the letters and the numbers, doesn't it? Clausing?
X, A times B.
Yeah, X to the AB. X to the A B power. You just multiply those two together like I multiplied them. That is your 3rd law of thermodynamics. I'm not sure that's what it is, but it could be. Do you think that you have a handle on that? Of course you don't. Here we go. Ready? I'm going to throw up here a whole bunch of examples and see how many of these you can get right. Are you ready? X to the 5th times x squared. X to the 5th divided by x squared, x to the 5th squared. 10 to the 8th times 10 to the 3rd, 10 to the 8th divided by 10 to the 2nd power. If in fact, children, you were asked to simplify those, what in the world would you come up with? The mental strain is excruciating today. Oh wait, then we should do this. How about this? Let's make one more. 10 to the 8th power cubed, just because we should round it off about 3 times. What say ye? Are we ready? You should be done. Kind of ish. Partially ish. Mostly ish. Let us start off in no particular order. Let's go to this one. Are you ready? What's 10 to the 8th power times 10 to the 3rd power? Using exponents. I don't want you to write out all the zeros because that would get really big. Joseph?
10 to the 11th power.
Very good. Equals 10 to the 11th power, because when you multiply bases that have exponents with it, you add the 10 to the 11th power, 1 with 11 zeros after it. How about this one? X to the 5th squared. Caleb Fisher, x to the 5th squared is?
X to the 10th.
The 10th power. Exponents, 2 exponents get multiplied. I don't know why I wrote 7. I said 10. How about this one? X to the 5th over x squared. X to the 5th over x squared is, Lauren? X to the 3rd power, yep, because you subtract 2 from 5. How about this one? 10 to the 8th power cubed. 10 to the 8th power cubed. Exponents, 2 exponents. Madison?
10 to the 6th power.
10 to the 8 times 3 is 24, did you say? Where does 6 come from? I got 10.
Oh, I did it wrong.
I get 10 to the 24th power. Exponents, 2 exponents get multiplied. How about this one? 10 to the 8th power divided by 10 to the 2nd power. Layton?
10 to the 6th power.
You subtract. And the last one, x to the 5th times x squared is Sarah Grace.
Okay.
This one. The only one that doesn't have blue.
X to the 10th.
What's that?
X to the 10th.
X to the 5th. Here's 5 x's times x to the 2nd. Are there 10 x's there? Like bases with exponents get added together.
Oh, sorry.
This was 10 to the 10th because it was an exponent to an exponent. Who thinks they have a relatively firm grasp of reality? Really?
No.
That is